Hello again to another Agakala React. And today we'll be watching Acid Rain and the Sneaky Policy That Solved It from Cheddar, and Cheddar explains. So let's just see. We're gonna just say something. I remember as a child, I heard quite a lot about acid rain in America, like New York, Los Angeles, that they were kind of, all those big, massive cities in America that they were. I haven't heard about anything like that in a really long time. So let's just see how they solved it. Let's just see how they fixed it.
Summer is fog season in San Francisco. These thick layers of fog are chilly and damp, but they won't deter determined runners or cyclists. The 70s and 80s, however, were a different story. Back then, the fog was often 10 to 100 times more acidic than it should be. SoCal was even worse, with fog closer to the acidity of lemons than typical water. Acidic precipitation like this was a huge global problem, although if you've heard of it, it's probably acid rain. Sorry, fog. Acid rain wreaked havoc around the world. It rendered lakes inhospitable, killed forests and crops, and even corroded Mayan ruins, not to mention the effects on human health. But today, acid rain is behind us. We solved it. It's an environmental crisis story with a happy ending. Mostly. Kinda. We'll get to it. Acid rain is exactly what it sounds like. Rain that is more acidic than it should be. We measure acidity using the pH scale. More acidic over here and less acidic over here. Pure distilled water is right in the middle with a pH of 7. Moving from one number to the next is a tenfold change. So pure water is 10 times less acidic than milk and 10 times more acidic than ocean water. And normal rainfall is actually right here, which I found confusing, so I called in reinforcements. I spoke to a science teacher with a master's in chemistry and atmospheric sciences from MIT, who's also my sister.
So it turns out that normal rainfall isn't perfectly neutral because normal rainfall has other chemicals in it. Carbon dioxide, CO2, is the thing that's responsible for even normal, unpolluted rain to not be perfectly neutral pH water. But it's not a concerning amount of acidity.
But you know what was concerning? When in the 1960s, scientists started finding rain with pH levels as low as 2.8 or even 1.7. Now, if you think you know the root cause of all this extreme acidity, you're probably correct.
Pillars of smoke by day, pillars of fire by night, pillars of progress. Machines to make machines, production to expand production.
You know the story. Some countries started burning a ton of fossil fuels, which sent carbon dioxide emissions skyrocketing. But I'm actually going to put a pin in carbon dioxide for now, because while it is a culprit in this story, it's not the main culprit.
The two acids that started becoming the big problem are nitric acid, HNO3, and sulfuric acid, H2SO4. And so they are based on nitrogen oxides and sulfur oxides, which are chemicals that have specific known industrial sources.
For simplicity's sake, I'm just going to call the emissions themselves NOx and SOx, and their respective acids, nitric and sulfuric acids. Okay? Okay. Speaking extremely generally, SOx arrived on the scene first, thanks to the really sulfur-rich coal that drove the first wave of the Industrial Revolution. NOx came a little bit later because it primarily comes from the burning of gasoline by power plants or cars. But both sulfuric and nitric acids are way stronger than carbonic acid. So as more and more of them piled up in the atmosphere, the water up there became increasingly acidic. But it took about 100 years, give or take, for anyone to notice. By which I mean the scientists noticed, and probably people living in affected areas noticed. Acid rain was killing forests, fish, and crops. It was making normally cloudy lakes eerily clear. It was corroding buildings, and it was exacerbating heart and lung problems. But the first real attention acid rain got came in a 1967 edition of this Swedish newspaper, Dagens Nyheter, courtesy of this Swedish scientist, Svante Odin in an article entitled An Insidious Chemical Warfare Among the Nations of Europe. I'm sorry to all the Swedes. In it, Odin blamed emissions from other European countries for acidifying Swedish rain. Now this got a lot of Swedes in a tizzy, but it still didn't make major waves much beyond that. Because at that point in time, scientists had yet to prove something that seems kind of obvious in retrospect, that pollution can move.
If you think about the problem of soot, for example, those are particles that are like visible to the eye, right? But the thing to know about gases is that particles of a gas are like a molecule, like unimaginably small.
Meaning NOx and SOx can drift a long way from their sources. But we didn't have concrete proof at the time. Previous research had already found that nuclear fallout can cross continents, and that pesticides can make it as far south as Antarctica. But what types of pollution could travel and how far was still up for debate at the time. So throughout the 1960s and 70s, scientists all over the world are working really hard to pile up evidence that, yes, emissions of NOx and SOx are causing acid rain, and that, yes, they can travel really far from their industrial sources. So slowly but surely, more and more people boarded the acid rain train, or rather the anti-acid rain train. But if you follow environmental news, you know what comes next.
But more importantly is the issue of whether further control of SO2, which is a specific pollutant and one dear to the coal industry, will in fact make any reduction in the acidity of rainfall.
That's William Poundstone, a major coal industry executive. In this clip, Poundstone is debating a top EPA official, Douglas Kossel. The whole show is linked below if you want to check it out. Poundstone exemplifies the strategy of the fossil fuel industry at the time. Sow doubt about the science of acid rain, and warn about the dangers of moving too quickly to curb emissions. And the industry found strong allies in the renewed conservatism of the Reagan and Thatcher administrations. The US Congress rejected 70 bills about acid rain during Reagan's tenure. And fair enough. Limiting emissions didn't seem all that appealing after 150 years of transformative economic growth, not to mention the energy crises of the 1970s. But by the 1980s, the situation was becoming pretty hard to deny.
On one occasion here, an Englishman caught 80 salmon in a single day. Now, thanks to the effect of acid rain, only 4 have been caught in a year. And this is southern Norway's cleanest river.
On issues like acid rain, the White House has turned down action.
In Germany, it's alleged that half the country's forests have been damaged by acid rain.
There are tons of examples to look at here, but I want to focus on Canadian lakes. Emissions from the coal-happy US Rust Belt did not respect Canadian sovereignty. They drifted across the border, acidified Canadian rain, and rendered a lot of lakes inhospitable to life. It quickly became much more than an environmental problem. It ballooned into a thorny political spat that the Los Angeles Times called the single greatest irritant in US-Canadian relations. When Reagan visited Canada for the first time as president, he was greeted by thousands of protesters shouting, "Stop acid rain." Finally, from the mid-80s to the 1990s, enough political pressure mounted worldwide that countries took action. European nations got together to pass protocols limiting SOx and NOx emissions in the 1980s. In the US, President George H.W. Bush updated the Clean Air Act in 1990 to implement a cap-and-trade system for reducing emissions. Power plants that used cleaner fuel sources like low-sulfur coal or filters that trapped emissions could sell their allotment of emissions to other power plants. Oh, and Canada and the US became friends again to sign an emissions reduction agreement in 1991. And it worked. Emissions in both North America and Europe plummeted from the 1980s through the 2000s. I told you this had a happy ending. Kind of. Yes, the countries that had already enjoyed 150 years of burning as much coal and gas as they wanted, they cut emissions. Although some worry that levels are still too high for affected environments to recover. And in other countries that began industrializing more recently, emissions of NOx and SOx are still increasing. But remember how I put a pin in carbon dioxide at the beginning of this video? It's time to unpin. Everyone's heard of carbon dioxide as a potent greenhouse gas that traps heat and warms the planet. But now, enough of it is piling up in the atmosphere that it's becoming a potent acidifying force. Not of rain, but of oceans and lakes. We've known about the ocean problem for a bit, as the average acidity has increased by about 30%. But more recently, new evidence suggests that the same thing is happening to freshwater lakes. I mean, we just can't win. Reducing carbon dioxide emissions kind of feels like the final boss battle in a video game, so hopefully we can do it. My apologies in advance to Canada's lakes. Did you know Ontario has 250,000 lakes?
Wow.
That's wild.
I
That's
did not
so
know.
many lakes.
That is a lot of lakes. Wow.
I moved the mop handle. See that? Like if your favorite acid rain causing emission is SOx, and subscribe if it's NOx. Or just do both. And leave a comment if it's carbonic acid. Or do all three. Alright, that's enough.
She's funny.
Goodbye.
Goodbye. Okay, so I'm gonna have to say one thing.
Summer is fog
no,
season.
wait. We're not watching this again. So she kinda explained, like, yeah, I haven't been born in 70s to remember about the acid rain, but then I was born in 80s in Poland, but I don't remember ever kind of hearing about the acid rain happening in Poland. But I did remember mention of it in TV, like in America, like I said in the beginning of the video. Like movies and stuff, so maybe I was watching some old movies. But it's kind of like with ozone hole in the sky that was sorted as well, isn't it? Like when the world want to work on something and fix it, we can do it. We just have to have same mindset. But I kind of start finding that more and more people don't want to work together because they think that they're right and they can't be wrong. Even when they see arguments saying that they are wrong, they're still gonna be saying that they're right. And they just don't want to work with other people. So, yeah. Anyway, what did you think about it? Did you happen to ever seen an acid rain? How did that come out? Because I'm kind of curious now. I don't want to see it. But maybe some old videos and stuff. Thank you very much for watching, and I'll see you tomorrow. Bye!